Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. In this lesson, I'm going to talk about the inverse of a function and how to calculate the inverse of a function. So I'm just going to go through different examples as you see, and we will look at all these where we look at the inverse of a function. So number 1 to 6. So I just want you to pay attention. It covers almost anything that you will need, especially when you're calculating the inverse of a function. So let's start with the first one. How do you find the inverse of a function? And you are given number 1 now. It says f of x is equal to 2x minus 4. So how do you find the inverse here? Now for you to find the inverse, first of all, you make that become to y. So f of x becomes y is equal to 2x minus 4. And then you interchange. Where there is x, you make it y. Where there is y, you make it x. So we have what? Y becomes what? Y becomes x is equal to 2, and x becomes y minus 4. Do you see what I did? You just have to interchange. So I started first. F of x becomes y. Y becomes x. 2x becomes 2y. You just interchange. And then from there you make y the subject of the formula. So what you have got x is equal to 2y minus 4. You take 4 to the other side, it's negative, it will become what? Positive. So now you've got x plus 4 is equal to 2y. And then from here you need to make y the subject. Remember, you don't want that 2, so you divide by 2, you divide by 2. Then you have got y is equal to x plus 4 over 2. But one way that is most proper, you can even write it like this: y is equal to, because this 2 affects the x and the 4, is allowed to write it as x 1 over 2x, or x over 2 first, just to show you this. It's x over 2 plus 4 over 2. So now y becomes x over 2 is half x, and then 2 into 4 is plus 2. See, you have managed to write the inverse. So how do you write it? So if this was f of x, so this is how you write it: inverse with a negative 1 of x, or you just say inverse is equal to 1 over 2x plus 2. Are you getting that? So this is the inverse of what? Of f is equal to 2x minus 4. So that is that. Let's look at the next one. The next one here is, we're looking at f of x, number 2. It says f of x is equal to what? X squared. We want to find the inverse. Remember, you convert it from f of x, you make it remember, f of x is actually y. So f of x, make it y. Y is equal to x squared. And then after that, I'll use this sign to say you interchange. Let y become x and let x become y, but now it will be y squared. You see that? Then after that, you make what? Y the subject of the formula, because you must say y is equal to. So what you do, you are given x is equal to y squared, or you can interchange here to have y squared is equal to x. Y squared is equal to x. How do you get rid of that power? You square root both sides. Are you seeing that? And then you have now y is equal to square root of x. But it's always good to say plus or minus. We will discuss later on the inverses where you have to restrict the domain, the restriction. But you must remember it's plus or minus x. That is the part. Let's look at the next one. How do you do number 3? Number 3 is here f of x is equal to 5 to the exponent x. How do you find the inverse of that? Remember, first things first, change f of x to become y. So it to become y is equal to change. Now look what do you do now? On the other one, you are changing that. Since f of x is, okay, before that, let's write it. This is f of x is equal to 5 to the exponent x. I was going ahead of myself. Now that's where it comes the interchanging. I don't want to use this sign as such, but let's come to this part. I'll write interchange. It's better to use this. Interchange. X becomes y. Y becomes x and 5, but x becomes y. Do you see that? You have to interchange. Where there was y, you put x. Where there is x, you put y. Then from here, you make y the subject of the formula. Let's rewrite this as 5 to the power y is equal to x. Are you with me? Now, for you to make y here, you have to introduce logs. But there is a simple way that you can write the logs. Now, this is how you can do it. Remember, this is the base, and that is the exponent, and this is the number. So now, if you want to make y the subject here, you must write it like this. It says log. Remember, here we have the base, and then number equal to exponent. You can use this concept. Log base number equal to exponent. Now you take as is to say log. Okay, let me do with this. Look at this. If I say log, now what is the base? The base is 5. You see, this is my base. So log base 5, and what do I write? The number, and the number, there it is my x, is equal to my exponent, and my exponent is y. Look, y is now the subject of the formula. Then you have got y is equal to log base 5 of x. Are you with me? Another thing you can do, it's not really a must to master this part. I don't want to cram it in a way, but you can write it like this. Look, if I say to you 5y is equal to x, I just say introduce logs on both sides. You say log 5 to the power y is equal to log x. You just introduce logs, and then after that you drop this y here. According to the laws of logarithms, it will be y log 5 is equal to log x. Then from there you have to divide by log 5 and divide by log 5. Then if you do that, cancel, then you've got y is equal to, now when log 5 is dividing, then you can write it as that base there, and then you have x. Are you with me? So that is another way you can just do that one. So that is that. Let's look at the other one. The other one is number 4. Number 4 is f of x is equal to what? Is equal to 1 over 5 to the power x. And then you have to do an inverse. Find the inverse. First things first, f of x becomes y is equal to 1 over 5 to the exponent x. And then what do? You interchange, meaning x becomes y and y becomes x. So this one, it will become x is equal to 1 over 5, and x becomes what? X becomes y. Then you make y the subject. If y is an exponent, I repeat, if y is an exponent, then this becomes the what? This becomes the base. And then this becomes the number. And then what do? You write now, whenever y is an exponent, you know that logs are involved. Then it becomes log. The base of a log is there. The number of a log is there, is equal to exponent. Then you write it now as the final answer becoming log. Now the base is 1 over 5. Please write it as a small thing there, like like a base, like just in small, so that you can be able to put your number straight there. All right, so log and then number is equal to exponent, which is y. Are you seeing that? And then someone will say, but how can I solve this using the general or the basic laws of logarithms? You just do this. Remember, y is equal to 1 over 5 to the exponent x. Are you seeing that? Then introduce what? Logs. Sorry, it was not. I need the one that I'm supposed to change is the other one. I'm supposed to change this one here. It's x is equal to this y. So I'll say just put logs on both sides. Log 1 over 5 to the power of y. Then this falls down there, becoming log x is equal to y log 1 over 5. This helps you not to cram things. Now you want to remain with y. This is multiplying. Divide by log 1 over 5. Divide by log 1 over 5. Then when you cancel that, you'll say therefore y is equal to, when it's at the bottom like this is same as log in base 1 over 5 of x. Are you with me? So if I just say to you log base 10 over log 5, this is same as log in base 5 of 10. Just test it with the calculator just for proof's sake. Let's say bracket log 10 over log 5 like this. Are you with me? Equal to, you see I'm getting 1,43. So if I say this one log it's 1,43, let's try this one, log base 5 of 10, and see if I'm getting 1,43. There it is. Do you see that? So it helps you just to know it is that. Let's move on. We're still doing the inverses. Inverse of a function, number 5. Let's calculate the inverse of a function. What do you have here? Log base 4 of x. That is f of x. It's f of x. That's number 5. So f of x is equal to that. So what do you do first? Make that y. So y is equal to log base 4 of x. Then what you do next, you interchange. Y becomes x and x becomes y. Are you with me? Then from here you have to now make y the subject. Now let me give you this when you're making y the subject. If I give you log in base of a of b is equal to m. Look at that. So a is the base. It means therefore I can take a to the exponent m is equal to b. Remember, we're moving back. This is the base. This is the number. And this is the exponent. Am I right? Let's look at that. If I then do that, this is the base, this is the number, this is the exponent. So how do I write it? I start with the base, which is 4. Now to the exponent x is equal to y. Are you seeing that? That is that. Or if I'm using this rule, look, I will have here log in base 4 of y is equal to x. I'm using this rule. So I've got that. My a is my 4, my b is my y. So a, which is 4, m, which is my x, is equal to y. See that? Whatever case, you have to be comfortable with that. Alright. So lastly, let's look at the last one. Finding an inverse, number 6. What does it say? It says you are given f of x is equal to log 1 over 4 of x. Now, some of you, this is how you write your logs. Just be careful. Some they write it like this, log 1 over 4 of x. you can't tell which one is the base, which one is the number. You avoid that. Some they write it like this: log 1 over 4, then they write x on top there. Some they write log 1 over 4, then they write x like that. You'll get things wrong. These are wrong. Why? Because you need to align them properly. X must not fly out as an exponent. So you write it is log. Now there is something down there and on the number. You see that? Even if you take a calculator and have a look at the calculator. If I'm bringing a calculator, look at that log. You see? This is how you write it. The number there, that's where you put your 1 over 4. You see where the calculator does it? And then your x or any number there, 6. That's how you must be writing it, okay? So be careful of that. So we have that. Now let's follow the rules. We're making this an inverse. Convert that. Remember this is y, which is log base 1 over 4 of x. Right. Then from there, what you do, you interchange x, y becomes x is equal to log 1 over 4, x becomes y. Then from there, it's you to remind yourself to say what is what. With a pencil, you write this as the number, this one as the base, that as the exponent. Right? So you start with the base. Remember, when you're writing exponents, you start with your base, which is, for example, a to the power of x is equal to b. That's what you're writing. So when you're writing it also, you start with the base to say 1 over 4 to the exponent x is equal to y. There it is. Or I told you, you can use this concept here, the law which says, if I say log in base a of b is equal to m. If you're given that, you take that a, that is an exponent m, is equal to b. So we can rewrite this and say, what about our log 1 over 4 of y is equal to x. So how do I write that? My a is my 1 over 4. Put a bracket please. My m is my x is equal to my y. These are different ways but still achieving the same thing. So guys, that's how you find the what. You find the inverse of a function. Now in the next lesson, you need to join me. I'll be now looking at functions where I'm looking at questions that involve the sketching of functions. For example, look at this question. It says consider the function that, write down the domain and the range, show that this is a one-to-one relation, determine the inverse, and then sketch the graphs. That's where marks are also very important for you to do that. Then we're going to look at also the exponential one, and we're also going to look at the logarithm one. Then with that, you wrap up this topic on functions. We've come to the end of our lesson. Remember to be subscribed so that you follow up. Thank you.